Thank you so much for watching this channel. I know that on a normal day, you don't like to subscribe to YouTube channel. However, please kindly like and subscribe to this YouTube channel. I do encourage you to watch this video to the end and do not forget to subscribe to this channel. Kindly like and share this video, please. Thank you so much. And you can put your questions and comments in the comment section below. You can be sure that your comments and questions would be attended to. Thank you so much once again. Yes, I know you haven't subscribed yet. Go and subscribe now. Thank you so much. All right, so today we are going to be dealing with a very, very important topic. We are going to be dealing with a very, very important element in a building, okay? And we are going to be dealing with stairs, its design, and detailing. We're going to be dealing with both the practical and the theoretical form of it, okay? So I want to welcome you again to this YouTube channel, and I encourage you to do subscribe and share, okay? So we are very glad that you have decided to learn with us, and you can be sure that this lesson is going to worth it. This time that you have dedicated to learn with us is going to worth it, okay? So today, just like I said, we're going to be dealing with stairs. And if you ask me, what are you going to learn today? Okay, so I am going to tell you that at the end of the lesson today, you should be able to define stairs. You should be able to have a definition of stairs. Then you should be able to understand the terms used in stairs. You should be able to list and explain the types of stairs. There are different types of stairs, okay? So you should be able to list the different types and explain each of them, okay? So you should be able to understand the general requirements of each of these stairs. So all these stairs have their own requirement, okay? I understand that stairs itself has a general requirement, but each of these tier types also have one thing or the other that are peculiar to them, and you are going to learn it today. All right, so you are going to be able to design and detail a stair. Yeah, you will have an idea of design. This particular video doesn't cover the design per se. It doesn't cover everything about the design, but it's going to give you an hint on the design and then the detail of a stair. So just sit back and relax and enjoy the lesson, okay? So where do we start from? The definition is quite explanatory. A stair is a series of steps or flights leading from one floor to the other. I'm going to take that again. It is a series of steps or flights leading from one floor to the other. So for you to have a stair, there must be floors. There must be a vertical distance. There must be a distance you are trying to bridge. Okay, so that is where a stair comes into place. I'm going to define stair again as a structural element that enables access to a vertical distance. I understand that we do not really need to drag this definition very much, because you would have come in contact with stairs and you know what a stair is, okay? So I'm not going to dwell much on the definition. However, I need you to understand the general concept of the stair itself. Okay, so it's a structural element that enables access to a vertical distance. In other words, stairs are structures that are designed to bridge a vertical distance between lower and higher levels, okay? So in our different homes, most especially homes where we have one or more floors, you know, in the building industry today, we now have multi-story buildings. Initially, it used to be just bungalow. Later, it's, you know, with the help of structural engineering, we now have multi-story building. We can now build as many stories as we want. And each of the floors has to be connected. A lot of different elements can be used to connect it, but I'm talking today particularly about an element called stair, which we can use to bridge the vertical distance, okay? So stairs generally can be made of timber, it can be made of reinforced concrete, it can be made of steel, can be made of stone or composite materials. What I mean by composite materials is a combination of any of the other materials or a combination of two or more different materials, okay? So you can decide to make your stair of timber and reinforced concrete. You can decide to make it of reinforced concrete and steel. You can design to make it of a timber, steel, and reinforced concrete. And you can decide to just make it of timber. You can say just make it of reinforced concrete, steel, stone, or a combine, or even all of them. Okay, so it depends on what exactly you want to make. You want to make your stair of. So stairs generally can be made of different materials, and these materials include timber, reinforced concrete, stone, and steel. Okay, so today, there are a lot of terms used in stair, and I can tell you for free that a lot of people confuse themselves, most especially when it comes to understanding the terms used in stair. And so today, I am going to talk more on the terms used in stair. I have a list, I have a very, very long list of them, and we are going to deal with it today, okay? We have number one, we have the tread. The horizontal part of the step where you place your foot is called a tread. That horizontal part where you place your foot when you are climbing a stair, that is what a tread is. Okay, so I'm really going to move to the riser. The riser is the vertical part between two treads. So if you have your left leg, let us say that there are, in a stair that there can be a lot of treads. Yeah. And let's say you place your right leg on the first one and your left leg on the second one. There is going to be a vertical part between the two threads where you are placing your leg. That vertical part is what is called a riser. Okay. So there is something called going. A lot of people misplace the going for the tread. However, the going is more of a measurement. So the going is the horizontal distance between the faces of two consecutive risers. So if you are told to go and measure your tread, it's more like you are measuring your going. So when you are told that what is the going of a stair, what it means is that what is the measurement of that tread of the stair? What is the measurement of the tread of the stair? And that is what a going is. Just like we have the going, we have the rise also. And as the going is for the tread, the rise is for the riser. So the rise is the vertical distance between the top of two consecutive treads. So that vertical distance, we said if you place your right leg on a particular, on the first thread, and then you place your left leg on the second thread, the vertical distance between the top of the two threads you are placing your leg is what is called the riser. Sorry, is what is called the rise. The distance is the rise, then that part is called the riser. Okay, so there is something called a stringer. A stringer is the main structural member that supports the threads and risers. Okay, there is a baluster. That is a vertical support or spindle, often decorative, that support the handrail. A lot of people confuse balustrade, and the handrail, but today we are going to throw more light on it. So just as I have said, a vertical support or spindle that helps support the handrail is what is called a baluster. The handrail itself is that horizontal or sloping rail intended for grasping by the hand for support. When you are climbing a stair, that part that you place your hand, that horizontal or sloping rail, that rail that slopes, where you grasp, that you grasp by your hand for support, is what is called the handrail, okay? So there is something called newel. It's a large, usually ornamental post at the bottom or top of a staircase. A large, usually ornamental post is it is always at the bottom or top of a staircase. It is always supporting the handrail. That is what the newel is. Okay, so the balustrade now, the entire railing system, including the balusters, the handrail, and sometimes a bottom rail, is what is called a balustrade. So let us not confuse ourselves when it comes to baluster, handrail, and the balustrade. So just like I have said, the baluster is the vertical support for the handrail. The handrail is that sloping part where you grasp with your hand. Then the balustrade itself is the entire railing system, including the balusters, the handrail, and sometimes a bottom rail, okay? There's something called a nosing, okay? That is the rounded edge of the tread projecting beyond the riser. When you look at some steps, you discover that there are some stairs where the tread is going to project a bit beyond the riser. You understand? It can be as low as just 25 mm and 50 mm. So that rounded edge of the tread projecting beyond the riser is what is called a nosing. Okay, and I'm going to be talking about the winder now. A winder is a wedge-shaped step used to change the direction of a staircase. Let us say let us say we have an half ton or a quarter ton stair, and then by the time you take your first landing, there can be a series of steps where the edge is different, it is a bit wider than where it is coming from. The edge is going to be a bit wider, and it's used to change the direction. So that is what is called a winder. I'm going to show you in a picture, okay? So a wedge-shaped step used to change the direction of a staircase. That is what a winder is. Then there is a landing. The landing is a platform between flights. Just like the word itself, landing, it's more like a place where, by the time you finish your first flight, you are going to see a landing before you take off to the next flight, okay? Then flight itself is a continuous series of steps without a landing. That part of a stair where you have series of steps without a landing, before the landing rather, is what is called a flight, okay? So there is a pitch, that is the angle of inclination of a staircase, usually measured in degrees. Then we have some other one, we have the run, we have the rise. Just like I told you the other time, is the vertical distance between two consecutive threads. Then we have other terms that includes guardrail, step rake, head height, total rise, slope, channel, carriage, and so on, okay? So we have a lot of terms that can be used in stairs, or that are used in stairs. Okay, so this is a picture showing a bit of those things that I have mentioned before. Let me show you the very important one. All of them are important, but the one that are mostly used, this is the tread. That's the horizontal distance where you place your feet. That's the tread. So if you are measuring this thread, that is what is called going. Just like I told you, this is the riser. And if you are measuring this riser from this point to this point, that is the riser. That is the rise rather. Okay, so we have a landing here too. Here is the landing. And this is the winder I talked about. It has helped you to change the direction. You know, for somebody that's coming straight and you get here and you intend to change the direction. So you can easily change your direction like this. And that is going to be possible with the help of a winder. Okay, so I was talking about the baluster, the balustrade, and then the handrail. This is an handrail. This is an handrail. So the vertical pole that helps to support this handrail is called the balusters. While the whole system, the whole handrail system is called a balustrade. So we have other ones like the base rail, the gallery balustrade, flight balustrade, wall rail, closed stringer, cut stringer, and some others like that. Okay, so I'm going to move to the next one, to the different types of stairs that we have. Okay, so we have different types of stairs, and I'm going to be dealing with a lot as I can remember for now. Okay, so we have a straight flight stair. This is a picture of a straight flight stair. It's more of a stair without a landing. Okay, so let me quickly talk about the design of a straight flight stair. The design of a stair generally is similar to that of a slab, except for one or two different differences that they have. For a stair, you have to factor the slope when you are designing a stair. Okay, so this is a straight flight stair, and if there is anything that I would like to talk about this straight flight stair is that I have seen a lot of people that would construct a straight flight stair, and after the construction, they would eventually have to put a support below the straight flight to support the straight flight. You would see a lot of it around. After the construction of the straight flight, you would just see something like a column. They will just put column, and most of the columns are always introduced after construction. This is a problem, and it is a design problem. It is because the design was not properly done, or there was no design at all. Okay, so you should be able to cater for your deflection very well when you are dealing with a straight flight stair, because it is more prone to deflection because of its because of the length of the stair. You understand what I'm trying to say? So the straight flight stair must be designed against deflection, and you should be sure of what you are doing before you specify. You have to design, get good specification, and when constructing, you must stick to your design. Your concrete grade must be what it is. Then every other thing must, be according to what requirements or what factors you have used in your design. Talk about your strength of steel and then your concrete strength also. Then your spacing must be thoroughly adhered to. So it's something that requires thorough supervision, as simple as a straight flight could be, because if it is actually a simple thing to do, a lot of it has failed. And if it is simple to do, it shouldn't be failing as it is failing in the construction world today. Okay, so we have another one. This is the half ton. This is what an half ton stair looks like. This is what it looks like. This is what an half ton. So an half ton is more of a stair that has two different straight flights connected with a landing. You get it? So this is what exactly it looks like. So we have another one, quarter turn. Let me say categorically that a half turn is also called a 180-degree steer. Okay, so we have another one called a quarter turn or a open well. So it is called an open well because of the gap that it forms in between it. Okay, so it has more, it has three flights in different directions. You understand? So by the time, this is a flight. When you get to this landing, you continue another one, then you go straight. So there is this gap in between, and that is why it's called an open well also. Okay, so we have the cantilever steers, just like the name cantilevers. You just have it cantilever. You just see the steps projecting out of a central beam. Okay, so that is a cantilever steer. If there is anything to talk about in cantilever steer, is the fact that for the fact that it is cantilever, you have to design the steers. You have to design the steers, and you must consider the fact that you are designing a cantilever steer. Okay, so I'm going to be talking about the helical steers. Okay, so an helical steer, if you look at the shape from one floor to another, you will discover that the shape itself looks like an helix. And it is always a single, it's always a straight flight turning as it rises. Just like you see, it is a straight flight turning as it rises, you see, okay? And one very important thing structurally for this kind of stair is that torsion at the end of the stairs must be taken care of. There will be torsion at the end of the stairs, and this torsion must be taken care of. And I'm not going to recommend a reinforcement that is less than 16 mm at 200 top and bottom. It's going to be doubly reinforced. And I'm not going to recommend a reinforcement provision less than 16 mm at 200 mm center to center, top and bottom. Okay, so let's not make any mistake. And that is going to be even for normal residential buildings. Okay, so you have to do your design rightly and ensure that you are recommending adequate reinforcement. Okay, there is another one called the spiral stairs. So generally, a spiral stair would always come with a central or a center round column, and that is where all other stairs are going to project out from. Okay, they are the most economical in terms of space utilization and cost. When you talk about space utilization and cost, the spiral stair is the most economical, and it consists of several cantilever stairs coming out from a central circular column. And each of these stairs they are designed as cantilevers. Okay, I would not advise that this spiral stair is constructed in situ. I would advise that the spiral stair is constructed as precast, because a lot of spiral stairs that are constructed as in situ are always rough. This is not to say that you cannot construct your own as in situ and it will be neat. That is not to say that. However, I would advise that you do a precast if you want a very good job without stress. You understand? So that is that about stairs and the types of stairs. And I would also want to add that there is a stair called free land, a free stair, or a freestanding stair rather. So a freestanding stair is more like It's more like an half-ton stair without any support at its landing. It's not connected to a beam, it's not connected to a wall, it's just freestanding. And you just see it go from one floor to the other. You will see the landing and there would not be anything supporting the landing. That is a freestanding stair. And you should be sure that your designs are appropriately done before you recommend for that kind of stair. You must do your design very well for that kind of stair because there is no support in the landing, and you can imagine what the forces that the stairs is going to be subjected to. Okay, so I'm just going to proceed now, and I'm going to proceed to, for best proportions of stairs, your going plus 2 times rise should be equal to 580 to 600 mm. Okay, don't say that because I have said going plus 2 times rise must be equals to 580 to 600 mm for best proportion. You will now say that, okay, you can just make your going to be 100 mm and, make your rise to be 250 so that by the time you do 100 plus 2 times 250 is going to give you 600. No. The going and the rise also has their range of values too for best proportion, okay? And that is, your going should not be, should be less than or equal to 225 mm. Okay, so it should not be less than or equal to, rather, I want to say. So going less than or equals to 225 mm and the rise greater than or equal to 200 mm should be discouraged. So if you have a going that is 200 or 225 itself, it is not very good. And if you have a rise of 200 and above, it is also not very good. So you can use this range of values and design for your stair using the formula above. Going plus 2 rise equals to 580 to 600. Whatever your going plus 2 rise gives you, if it falls within 580 to 600 mm and you have not used a going that is less than 225 or equal to 225 and a rise that is greater than or equal to 200 mm and your answer falls within 580 to 600 mm, then you have done very well. Okay, so now I'm just going to move again and I'm just going to say thank you for your time and I hope you have learned something new. I'm going to open an AutoCAD file for stair details now. In the next 5-10 minutes, I just want to show us something in an AutoCAD file, so that we can see what the detailing looks like, okay? So this is a stair, and as you can see, this is the plan. And the recommendation for this stair is Y12 at 200. For this tier, Y12 at 200, that's for the members, while we have Y10 at 250 for the distribution bars, okay? So I am going to quickly show us something, and this is where we get it confusing a lot of times in the construction industry, okay? You would see that okay, let me start from the plan. Guys, look at the plan here. This is the main bar. This is the main bar. This bar is the one that is going to connect a support. There is a support here, and there is another support here. Okay, so this is more like the landing, but there is a beam there at the first floor, or yeah, at the first floor, and this is where the stair is coming from from the ground floor. So if we have something like this, and we have this landing here, what it means is that this bar coming like this is going to connect this support together with this support to give, and it's going to be our main bar for this flight. And on the same vein, this bar is going to be our main bar for this flight, while this bar that is going to that spans from here to here and connects all the main bars together is going to be our distribution bar. This is going to be, this is more like a representation of our top bar here, and this is more like a representation of our top bar here. This one. So there is going to be a top bar here, there's going to be a top bar here, there's going to be a top bar here, there's going to be a top bar here. So that is what the plan. Now, how does it really work out on site? How does it work out on site? Kindly note that this that I'm talking about would help you solve your steer reinforcement placement when it comes to your straight flight. It's going to help you when it comes to your half turn. It's going to still help you when it comes to your quarter turn also. So it's very important that you listen attentively to it. Okay, so once again, let me say that do not forget to subscribe to this channel. Put any question you have, put it on the comment section, and you can be sure that we are going to attend to it. Okay, so this is how it works out on site. This reinforcement you are seeing here, okay, let me use this. This reinforcement you are seeing here, this is it, right? 7Y12 OH at 200 mm bottom. That is our bottom bar, and this is it. This is it. This is it. All right, also, let me not forget to tell you that when you are designing your steers, most especially your straight flight steers, do not forget your waist. One of the reasons why our straight flight deflects today, a lot of it is a problem of the reinforcement, then the waist, the concrete thickness for your waist. Okay, so your waist is always this. You are not going to take into consideration the going and the rise, but just this part of your steer is what makes up the waist. You understand? So back to the reinforcement. This bottom bar, which is our main bar, comes stretched from here, comes like this. This is the bottom bar at this point. So when it gets to this landing, it is going to form the top bar. It comes straight like this, and it goes all the way up like this to come and form the top bar here. And that is how it is. So the question will now be, which bar is supposed to be the bottom bar here? In other words, this bar here, the bar here, which bar is going to form the bottom bar? So this bottom bar here is going to come like this and come like this to form the top bar here. So you are, in other words, you are going to have that your cross bar, that bar crossing each other. You are going to have that shape here. You understand? Which is very important when it comes to stairs like this. Okay, so this bar comes straight like this and forms the top bar here when it gets to the landing, and then the landing bottom bar comes like this and forms the top bar here when it gets to your flight. So on the second flight, the bottom bar The bottom bar coming forms your top bar here. This bottom bar forms your top bar here. Or better still, for better understanding, let me do something like this. So it forms your top bar here. Okay, so it comes this way to form your top bar here. While on the same vein, your top bar, sorry, your bottom bar for the flight, which is the main bar of the flight, comes this way and form the top bar here. It connects to whatever support you give to it here, you provide for it, okay? So when you get to the top here too, in similar vein, your bottom bar here is going to form the top bar at the top. It's going to come all the way like this and form the top bar at the top. Let me delete this so that you are going to understand what I'm trying to say. So this comes like this to form the top bar here, while the bottom bar is what is now going to form the top bar for your stairs. So let me also add that this top bar, normally for your design, for the sake of design, we do 0.25 times L, you understand? Or 1/4 times L, they are still the same thing. So if the distance from here to here is say 10 meters. So what we are saying is that of your top bar, the span of your top bar is going to be 10 meters divided by 4, theoretically. However, I advise that you use divided by 3 on site for practical reasons. I advise you use divided by 3 anyway, but you may choose to use divided by 4. That's 0.25. So basically, if you are using divided by 4, it is going to be 0.25 times the length you get. But if you are using divided by 3, it's going to be 0.333 times L. That is what's going to give you the length of this, your top bar, okay? So, and that is that about this type of steer. Talk about the straight flight, the 180-degree half turn or quarter turn steers. So I'm now going to move to the spiral steer. Talking about the central column, you're going to be having a central column, and then you are going to be having series of steers that cantilevers out from a circular column. Can you see? This is the foundation. This is the steps, the series of steps that cantilevers out, and then this is your circular column. This is from one floor to another. This is floor 0, this is floor 1, this is floor 2, this is floor 3, and this is floor 4, and it can continue like that, okay? So this is what your steps look like. This is what your step look like. This is what your typical thread look like. And then this is what the section looks like. You understand? You have, so you are going to be having a steel coming all the way like this, and it goes straight into this column, just like we have it here in this section. It goes inside this column like this. So that is what it is. I'm simply going to talk about the foundation for stairs. Normally we have different type of foundation ranging from deep and to shallow foundations. You get, so whichever type of foundation that you want to do must be the one that is suitable for your stairs. For this stair, you can see that it's more like a pad footing. You can do raft for your stair depending on your site condition. So there is no rule that says that your stair must come with a pad. No. Whatever foundation is suitable for your steer has to be determined and it has to be used. Okay, so that I just have to say that about that. You understand? And let me also say categorically that your waist is a very, very important factor when you design your stairs. And let me sound a note of warning, most especially to a lot of carpenters. Out there, you're going to see that a lot of carpenters would have, they would make a formwork that would allow you to have good depth of concrete or good waste towards your flight. But when you now get to the end, it will now become slim, meaning that your waist is not going to be uniform. That is not a very good thing to do. And I do encourage you to ensure that your formwork is thoroughly supervised, thoroughly braced, and your reinforcement is properly laid. Okay, so thank you so much for watching this video. If you have any comments, if you have any question, please do well to put it in the comment section and you can be sure that we are going to attend to it. Thank you once again for watching. Remember to subscribe. Thank you. And remember to do what? Subscribe. Bye.